Hello there, children. Today, we are going to keep working on solving trig equations. This educational experience is brought to you by your teacher of trig. That would be me, Mr. Faust. So let's get on with the going on. Alright, we are going to begin today by solving by factoring. Now, we've done this a wee little bit, so we're going to continue on with this with some more difficult problems. So let's take a peek of solving by factoring, shall we? Alright, so what I'm going to look at here is this problem. Cosine to the fourth x plus cosine squared of x minus 2 equals 0. Whoa. Cosine of the fourth. Not a big fan. So what I'm going to do, and we've done previously in this class, is a little u substitution. Or whatever variable you want to pick for substitution, anything other than that x, because it's sitting right there. I'm going to adjust this. Cosine of the fourth is a little awful to look at first. So what I'm going to do is go, listen, I'm going to make cosine squared of x equal to some variable. In this case, I'm going to pick b, or u, or t, or whatever you want to pick. Now, cosine of the fourth is really going to be a b squared. This will just be a b, and that will be minus 2. That equals 0. And everyone at this level is able to factor that. Now, why in the world am I doing this? Well, if you think about it logically for a second, when I do this, factoring that out, I set each factor equal to 0. And I go, okay, b equals 1, and b is going to equal negative 2. Now, when I do this, I've got something I need to think about here. I wasn't trying to solve for b, so I put the cosine squared back in. That would be very helpful. Now, what I end up doing here is looking at this problem and going, okay, how do I solve for cosine squared? Why, I just give it the old square root. Now, look over here. A square root of a negative? Yeah, not gonna happen. So when you get something that makes no sense like this, that one's out as a solution. I'll even do it in red. That one's no good, because I can't have a square root of a negative number. So that's gonna lead me to some false issues there, so I don't even have that. Over here, when I square root, I get the cosine of x equals 1, and the cosine of x equals negative 1. Now, if I were to limit this thing, like we're going to here, from 0 to 2 pi, because I'm tired of writing that pi n at the end and things like that, then what I look at, where does cosine equal 1? Why, that's going to be at 0 or 2 pi. Where does cosine equal negative 1? That's negative pi. Now, obviously, if these were not limited up here, I would have to go plus 2 pi n and things like that. But there are my answers. And so I move on. Oh, happy days are here again. Now, next on the docket, we'll be solving by rewriting using a single trig function. Alright, what the heck does that look like? Well, let's give an example of that particular situation so we can all understand it. Okay, so if I look here at this particular problem, I see one very important slight fact. There are two different trig functions now. Well, that's a bit of an issue. Now, I'm going to limit this answer from 0 to 2 pi, obviously, but as I look there, that's two different trig functions. Great. That's phenomenal. Not really a fan of this. So what I'm going to end up doing is I want to write it in terms of 1. It's like solving one equation with two variables. You really want to avoid that if at all possible. I don't want to deal with that. So I've got to switch them out. Now, the easiest one to switch out is the one with the squared term right here. Why do you say that? Because, and this is why we did all those trig identities that everyone so deeply loved so very much, is I can switch this trig identity out as 1 minus cosine squared x. Yes, indeed, that's a Pythagorean identity. Now look, even though one's a cosine squared there, and everything else, that's the other one's a cosine, I've got something I can work with because guess what? Now it's all one particular trig function. So when I do this as one trig function, and I distribute the 2, now I've got something squared there, but it's all cosines, so it's all good. And what am I going to do? I'm going to set it equal to 0 by moving everything over here, over to the left side, because frankly, I want to keep things positive, and I want to make that positive. So if I add it over, it'll be 2 cosine squared of x minus cosine of x, and then lo and behold, I will end up getting a -1 here. Now I can factor that. Now this comes into play depending how comfortable it is. Right, if you don't like this here, then you can use a u substitution again like we did for the previous problem, and just make your u or your b, your t or whatever cosine, and then factor it that way. It's up to you. The choice is yours and yours alone. Now because this is all new, I'm going to use some substitution there. I'm going to be a little narcissistic, and I'm going to put F for Faust, because I can. So I get this as minus F, and then 2F squared. So then I factor this. I put a 2F as in one binomial, and the other binomial I get an F. So then I put a +1 here and a -1 there. You can always FOIL to check it. And then I set each factor equal to 0. Now, when I do this, the key important thing to remember is that in the end, I'm going to have to substitute back. You don't want to fall into the trap of just leaving this as is and go, my answer is F equals this. Because that wasn't what you were looking for, by the way. You were looking for something completely different. So then I go over here, and I go, all right, F equals 1/2, -1/2. Well, that means cosine of x equals -1/2, and you have to go to your fancy unit circle there, which everyone should know and love. And here you get F equals 1. Again, this is a fancy unit circle problem, which you should have had memorized by now. Whereas the cosine of x equals 1, you can figure that one out in a second here. So take a minute and think about that. Hum, hum, hum. Now that you've pondered long enough, now you could write these in terms of degrees, or you could write these in terms of radians. I'm going for the radians because everyone likes radians. Even if you don't, I do, so you can deal with it. Now you have 4 answers here. Why do I only have 4 answers? Because remember, I limited them here. There you go. If you didn't limit them, you must include the 2 pi n like we usually did. Alright, not overly terrible. These are one of the worst ones because I've got to introduce my trig identities there. Now, on to our last little chunk here, and this is everyone's favorite. Solve by squaring. This is by far the most difficult one because it's going to include a little bit of 3 and 4 there. So let's take a look at what I mean by that. Solve by squaring. What the heck am I talking about? Okay, so cosine of x equals the sine of x minus 1. Now, unfortunately here, not only do I have 2 different trig functions in terms of sine or cosine, I've also got 2 trig functions that aren't squared, which means I can't use one of those neat little Pythagorean identities we've been so touting about for the last little bit. So I can square both sides though, because it's an equal operation on both sides. And why do I do that? Well, as you can probably start to ponder, I am going to I wouldn't use the word cheat, but I am going to introduce a Pythagorean identity to this problem. Now, what do you mean there, Mr. Faust? Said the class. Well, said I, this is cosine squared. Now, you do have to FOIL this, so don't get worried and freaked out about foiling. Everyone should know how to FOIL at this point in their mathematical careers. At least I would hope so. Now, why did I do this? That's a bunch of gobbledygook. I've got a bunch of sines over here and a lonely cosine over here. Guess what I can swap out? I think you have the idea right now. I'm going to swap you out for 1 minus sine squared. So this goes back to our previous example of introducing Pythagorean identities. I just had to do a little work to get there first. I'm forcing one in here because I want to try to reduce it down to one trig function. Now, once you have something like this, it goes back to the previous example before that, which is kind of nifty, about setting it equal to 0 and solving. I'm going to add sine squared x to both sides and subtract 1. So when I do this wonderful mathematical shenanigans, I subtract 1 from both sides, I add sine squared of x to both sides. What happens is I end up getting some wonderful, wonderful items here. Now, that gets me 2 sine squared of x minus 2 sine of x, and the constant terms are gone. So what do? Why, I just pull out a GCF is the first thing you should always try in factoring. They both have a 2 sine of x in common. That leaves me with sine of x minus 1. Now I have something times something equals 0. I can set both factors equal to 0. Now when you do this, you should really begin to start churning in your brains about that unit circle, because guess what you've got to use again? That unit circle. And if you don't have it memorized, it's not going to be that much fun for you. So I highly suggest that. That means sine of x equals 0. And now you can take a minute and unit circle away. So now get a little think time in there. Think, think, think. Alright, now that you've used your unit circle there, I think we can safely say that guess what? Sine of x equaling 0, well that's going to be x equal to 0 and pi, and sine of x equaling 1 happens at x pi over 2 there. Now some of you might say, well what about 3 pi over 2? That's -1, not applicable right there. Alright, moving on to the next problem. Now, the next problem is everyone's favorite, well, not really, because not only is it one that I have 2 different trig functions, they're secant and tangent. Oh, wondrous day. So, what you've got to do, again, they're not squared, so I can't use Pythagorean identities, so I need to relate something about them, so guess what I get to do again? I get to square them, which I know is everyone's favorite. Now, the reason people don't like these is not only am I incorporating one of the harder items that I have in terms of my trig functions, but I'm also including 2 that aren't immediately stare at the unit circle for a while until the answer just springs out at me. So I've got a little work to do. Now, again, I'm not explaining the FOIL step because that's something that you should really have down at this point. Whatever you do, don't just square that and square that, because you're missing the gooey, nougaty center of FOIL, which would necessarily be bad. Now, why did I do this? Because guess what, folks? Guess what now? Tangent, in fact, reduces down to 1 minus secant squared of x. That's a Pythagorean identity, which, again, you got to know those because it comes in handy. And now when I get that, what I end up having is this. Now that's all well and good. How in the world do I solve this? Well, remember, anytime I have something squared, I always set it equal to 0. And by doing that here, I have it equal to 0. I am going to subtract 1 from both sides and add secant squared x to both sides. And when I do this, I end up getting the following neat little items. I get 2 secant squared of x plus 2 secant of x. I factor out the GCF of 2 secant x, and that leaves me secant of x plus 1. You can set each of these factors equal to 0. I'll do that over here. Now 2 secant of x equals 0. And secant of x plus 1 equals 0. This is secant of x equals 0, which remember is 1 over cosine of x equals 0. Now this is secant of x equals -1. That's 1 over the cosine of x equals -1. Now over here, if you think about it, 1 divided by what value of cosine gets me 0? As you pause and think about that for a second, you realize that can't happen. I can't divide 1 by a number and get 0. So that's out. No, not allowed to happen. So that one, like we saw previously, is an invalid little problem. The other one here, what do I divide 1 by to get -1? Well, that would give me if cosine of x were -1. You can also cross multiply here if you wish. 1 equals negative cosine of x, cross multiplying. That's -1 equals the cosine of x. Where does that happen? That happens at -pi. Now, why am I just doing that? Because I am, again, going to limit this from 0 to 2 pi because I don't feel like writing the other one so many times. Done deal. Over here, if you cross multiplied, cosine of x times 0 is 0. You get 1 equals 0, and that can't happen. So, in the end, let's take a peek here. So finishing this off, let's take a peek at all of these. Now, as you take these all in, let's have a little fun with this. So, these are wonderful, wonderful properties. So the first is isolate trig functions. That means same name, same power. You isolate one trig function by itself and solve. Taking the square root, same idea. Same name, same power. You just get it by itself, you have the square root. Solve by factoring is the same name with different powers. So like you have cosines in there, but one squared. Yikes! Solve by rewriting using a single trig function. That's a different name and different power. One of them is squared. If one of them is squared, you can go right to this method. So that means using your Pythagorean identities. And lastly, solve by squaring. That's where you have different names like sines and cosines, secants, tangents, things like that. And they're all the power of 1. That's when you attack with this method. So again, isolating and solving by square roots are if you have the same name, same power for both of them. Solve by factoring when you have the same name, like all cosines, all sines, with different powers. You do there. Solving by rewriting using a single trig function, different names and different powers, one of them being squared. And lastly, solve by squaring, different name and the power of 1. You are now ready to attack the next lesson. Go henceforth and do.